In my experience, it's index law number 6 that gives students the most difficulty, and it gives people difficulty for a couple of reasons. First of all, it deals with indices that are fractions, which is really weird. We can't really get our heads around what that means in real life. What does it mean to raise something to the power of a half? I mean, to raise something to the power of 2 just means multiplied by itself. To raise it to the half, that's weird. You can't imagine half things times together. It just doesn't make any sense. But the great thing about algebra is that even when you've got situations like this that sort of don't fit into our normal understanding, the algebra can still deal with it. It can deal with weird situations. So here we have a to the power of 1 on n. So the first issue people have is that it's hard to get your head around what's happening. The second issue is that just this formula can look a bit confusing because we've got this n hanging out here and it's not really clear what it means. This expression here, I'll write that out again because it was a bit messy. This expression here, a to the 1 on n, means that we're dealing with a bunch of different cases where n can be lots of values. So this is the rule for a to the power of a half, a to the power of a third, a to the power of a quarter, anything where n is some value. Okay? What we say is that we're dealing with all of the expressions in this form. Okay, the form where we've got a to the power of 1 on something. 1 on 2, 1 on 3, 1 on 4, and so on. This would keep going. And we want to know, well, what's the result going to look like? So to start off, I'm going to look at, I'll rub that out, I'm going to look at this case here. Okay, what the heck does a to the power of 1/2 mean? Okay. We can get a feel for what this is going to mean, okay, by thinking about what happens if we square it. Let's take a to the half, and we're going to square it. Now, if we think back to our index laws, index law number 3 told us that if we've got something raised to a power, and all of that is raised to another power, we can multiply the numbers together. So looking here, I've got a to the power of a half raised to the power of 2. We can simplify that by making this a to the power of 1/2 times 2. And we all know that a half times 2 is the same as 1. And a to the power of 1, that's just a. However, we've just raised something to the power of 2, or we've raised a to the half to the power of 2, and we've gotten a as the result. Okay? We've squared this thing here, and the answer was a. Take a, raise it to the power of half, and then square it, and I end up with a. That's almost identical to this result that we learnt earlier. If I take the square root of a and I square it, I get a. Okay, the only difference between these two expressions, in this one I've got a to the half, in this one I've got square root of a. I'm squaring both of them and the answers are the same. So the only conclusion that we can draw from this, the squares are the same, the results are the same, is that these two things must be equivalent. A to the power of 1/2 must be the same as the square root of a. So I'm going to write that over here. Alright, let's think about the next case, a to the power of 1/3. And I'm going to cube this one. Now my index laws again, here's something raised to a power, raised to another power. That's like a cubed times 3. Sorry, it's like a to the power of a third times 3. Third times 3 is just 1. Hey, I'm back at a again. Now, we didn't do this as a law, but this is also true. Okay, cubing is the opposite of the cube root, so that tells us that a to the third is the same as the cube root of a. And we could go on like this. We're going to find that the a to the power of a quarter is like the fourth root of a, and so on. So rather than write all of these out forever, we can simply abbreviate this, okay, as if I take a to the power of 1 on something, then it's whatever root that was. Okay, so if it's a 3 here, then it's the cube root. If it's a 4 here, it's the fourth root. If it's a 2 here, it's a square root. And we normally just leave that 2 off because if we don't write 1, we assume it's the square root. So if it's 1 on n, then we say this is the nth root. Okay, which sounds a bit funny, but it just is a way of saying if it's a 4, it's a 4. If it's a 5, it's a 5. If it's a 2, it's a square root, and so on. So a to the 1 on n is equal to the nth root of a. So our surds are basically equivalent to having indices that are fractions. And that's the important thing to get out of this rule. Algebra cannot tell the difference between a to the half and the square root of a. They are equivalent statements. And if we really wanted to, we could abolish one of them. We could say we're always going to write them as fractions and never as square roots if we wanted to. This is a lot like in primary school when you learnt that these two things are just equivalent ways of writing the same thing. Okay? These two are equivalent ways of writing the same thing. A to the 1/2 is equal to the square root of a. That's index law number 6.